So moving forward, I would like to invite Patrick, who will be talking about how we can do monitoring with serverless tech. It's going to be exciting. Over to you, Patrick.
All right, great. Thanks, Rahul, for your warm introduction. And thanks again, everyone, for joining today's APAC track on Azure Serverless Conf. There have been some great sessions so far, and it's a good opportunity for us, Azure Serverless and Azure lovers, to gather around to share our passion, our experience, and potentially our lessons we learned in using Azure Serverless technology. So my today's topic is I'd like to show you how we can build a dynamic heat map and monitoring dashboard system using Azure Serverless. And coincidentally, I have also prepared a demo that's done in TypeScript. So if you enjoyed Melissa's session about using a JavaScript married up with Azure Serverless technology, do stick around, and hopefully you'll enjoy my session as well. A little bit about myself. My name is Patrick. I'm here working at SSW Melbourne. I'm a senior software architect. I see myself as a full stack engineer and public speaker. And a little bit more about myself. I have over 7 years of experience in IT industry, during which I have successfully designed, architected, and led and delivered a number of solutions to a variety of clients in different industries with a focus on fintech. My interest in technologies include IoT, big data, machine learning, AI, and most importantly, Azure and Azure Serverless technology. Over the last year or so, I've been using Azure Serverless technology extensively and helping my client building and solving their business problems and building applications like real-time voice and video streaming, as well as document collaboration. And if you want to find me on Twitter, here's my handle. If you'd like to be a little bit more formal, this is my LinkedIn. At SSW, each consultant has his own profile page. You can easily find it by Googling Patrick SSW. And in my spare time, I like to follow and sometimes contribute to some open source projects. I've been recently working on a conversational AI chatbot at SSW Public Repo, which can help you to find an employee in an organization with certain skill sets and availability. So come to my GitHub and check out my activity if you are also interested in AI. At last, there's a technical blog that I sometimes write. I see it as a good place for me to retrospectively summarize the experience I gained or the lessons I learned from my recent projects. All right, enough presentation, enough introduction. Let's look at the agenda. First of all, I'd like to show you and explain why we want to build Heatmap and dashboard system and why they are a good fit and the key elements in a contact tracing or social distancing monitoring system. And then we'll move on to introducing some Azure Serverless technologies and why I reckon that they are a good fit for us to design a solution to render and deliver our data and convey the information to the stakeholders that they are concerned about contact tracing and social distancing. I'll especially focus on Azure Signal Service and Azure Function. Then we'll move on to a design pattern that comes with Cosmos DB, but often ignored by developers, which is called the change feed and change feed design pattern, and why I believe that it can help us, and it's a best fit as the core engine of this Heatmap and dashboard system. Once we understand all the technologies, then we can bolt everything up to our overall architecture design, and then I'll move on to a quick POC, a demo, to show you how we can build this solution easily on Azure Serverless. Right. So as the well-known reason, since the COVID-19 pandemic started, contact tracing, social distancing, and yes, lockdown as well has been the new buzzwords. A lot of great solutions have been invented by technologies around the world to capture the contact tracing history, to measure the social distancing via some smart devices, either a watch or a smart lanyard or band, whatever. Now, we are able to collect the data from different channels like IoT or Event Hub, so on and so forth. Then, how to better visualize the data and serve it to the stakeholders and decision makers to take actions is the next challenge. And mind you, the people who want to look at the data are sometimes from non-tech background. So how we can promptly and attractively render the data in front of them would either help them or affect them in making decisions. A good way, I reckon, to convey the data is via heat map or dashboard. And if we think about that, if we ask a manager at a shopping mall to run a SQL report or to run a CSV report, then it may be annoying. But instead, if we can show a dynamic heat map and dashboard with a real-time updating chart in front of him, he'll tend to be attracted and find the most useful insight as he can. And we want our dashboard and heat map to be real-time. And also, we want the heat map or dashboard to be able to cater for a certain amount of dynamicity in the data, in terms of the types of the data. And why? Because, as I mentioned, we might be able to collect data from different sources, and the technology evolves very fast these days. So if the manufacturer decides to upgrade a certain smart device, then it's likely that the format of the data it collects is changed. So we want to keep the change at minimal level from our end in serving the data. We can make change, but we don't want to spend too much time in making the change. Once we have a nice dashboard system, it can be deployed to either a small venue, like a small company, startup, or a restaurant, or an enterprise level, a big building or a big stadium. Now, here's an example. Ayden is my son who's at his horrible 3, and apparently we are in lockdown, so we're not sending him to his childcare. But the childcare here at Australia works like this. So the kids are usually grouped according to their age, and they will be assigned to a dedicated room. So throughout the day, the kids will spend most of their time in the room that they're assigned to. However, these little creatures are very active. So the exception is that sometimes they want to go to other room to play with their friends or attend some classes. So this would affect the social distancing that we try to apply in the premise of childcare. The management team or the director of the childcare would like to know whether at some point of time, if there are more than, say, 10 people, including kids and educators in the room, and if that happens, they should take actions promptly. They should go there and bring some kids back. Now, so if we are going to build a solution, what we can do? So we need a smart device, of course, to detect how many moving objects, moving human beings in the room. And once we have data, imagine we have the data already, and how can we better render it? Of course, we want to set up a big TV screen on the reception desk and show a dynamically updated chart. So the management will notice that certain room has more than X amount of people, and they will take action. Now, we've understand the requirements. Let's explore some Azure Serverless technologies that can help us to build our solution. The first technology I'd like to bring up is Signal Service. Yes, Signal Service is one of my favorite Azure technologies. So, as we all know, Signal library has been very famous among C# or .NET developers, and almost is our default choice when we're trying to build real-time applications on WebSocket. It is great, don't get me wrong. However, By using Signal library, we need to manage the hosting and infrastructure ourselves. If there are tens or millions of client applications trying to connect to our hub that we hosted on the server, then we need to scale our server out or scale up to allocate more memory or compute power. All this can be done, but all this requires a lot of effort. Signal Service is a great choice in this case. So what Azure Signal Service offers is an abstraction so that you only need to have a turnkey configuration change. You are able to scale the Azure Signal Service up or out as you wish. Azure manages all the rest for you, and you can focus on implementing a logic in Azure Function as a serverless hub. So on the server end, if the Azure Signal service has an increasing amount of traffic, your Azure function can be scaled accordingly. And this all happens automatically. We don't need to worry. So we can focus on writing our business logic, which is great. And once we know how we can broadcast the information to a client application dashboard in our case, we want to find a best choice for a triggering point that we know that there are some data we want to broadcast. And I'll mention the change feed. And the reason why I think change feed is good is that there's a pattern that allows us to use change feed as central data store. I'll expand more about this. With that, let's look at a chart here. So, let's look at a diagram here. So we have our Azure Cosmos DB sitting here. And as I mentioned before, we can have data from different sources injected. And data ingestion is not today's concern, but we just know that we can ingest the data from either your IoT, your big data, your data factory, so on and so forth. Now, once we have the data arrived, change feed comes into play. It's going to capture the change in a document, either a document insertion or update. You might wonder why no deletion. I'll explain that later. But once we have some item appear on the change feed, we can do something subsequently. The first thing we can do is we can trigger an additional call to an external API. This includes Signal service, so that we can do additional things, react on the change on the Cosmos DB container, or we can use Azure Cosmos DB as a intermediate store in your entire data journey. And you might have some subsequent processing or data transformation tasks you want to perform subsequently. Or at last, we can do some data warehousing, like data movement between containers or moving data to Azure Blob Storage for backing up purpose with zero downtime and minimal impact on your live Cosmos DB. So here is the change feed design pattern in summary. It enables us to efficiently process a large amount of data, especially with a high volume of write. That's the nature of Cosmos. So we don't need to do anything in particular. And it is also a great alternative to querying an entire data sets to know the change. So traditionally, if you want to know what has been changed among a certain time frame in your data store, what we tend to do is that we will query a snapshot at the beginning of the time frame, and then we will query another snapshot of the entire database at the end time of the time frame, and then we will calculate the delta, the change. It works, but it requires a lot of computation power because we are querying for a snapshot of the entire database. So change feed is a great alternative to this. Every single change within the time frame is captured by change feed. So all we need to do instead is we can accumulate the each individual change up, and then it will be our delta. We don't need to do any calculation. We just add them up. That's it. And Cosmos DB is globally distributed, so the change feed is also globally distributed. So as an outcome, we can deploy our subsequent applications, either an API call or another data processing process or a data warehousing task as close to our consumer application or clients as possible. The key benefit of change feed pattern includes following. The first is a perfect as a central data store for event sourcing pattern. So in the typical microservice architecture or event-driven architecture, we will have some type of message queue. Cosmos DB change feed can be a great alternative to a traditional message queue. Why? The biggest benefit I see is that it supports multiple consumer applications subscribing to the containers change feed without any additional work in your infrastructure. So if we take a comparison with Azure Service Bus, if we are to set up multiple subscribing consumer applications in the service bus, we need to have a topic and we need to provision multiple subscriptions and allocate each consumer app a subscription. So with Cosmos DB change feed, in comparison, we can simply spin up as many consumers applications as possible as you want. All we need to do is provide it with a connection string, and that's it. And of course, from SpanOps perspective, there's no extra cost to utilize the change feed. Use it or not, it comes with your Cosmos DB engine. So we might as well just use it. If after we've looked at all the benefits, every coin has two sides. There's limitations. So the change feed is not an operational log, meaning that we can capture the change, but if you are looking for a full operational log of your database engine, your data store engine, the change feed is not your good choice. And only the most recent change of a given item is included. What this means is that if for some reason your consumer application somehow could be an exception in your logic or some downtime in your consumer application, that you miss that change item, then it's very hard for you to recapture it. So it's not suitable for application which looks for the ability to replay the past event or some dead letter queue management. So if you're looking for those, you'd better choose a traditional event queue, such as Azure Event Hub or Service Bus or Kafka. And the change feed in Cosmos does not capture the delete. So this is annoying, but there's a way to get around it. The way to get around it is that we can have a isDeleted flag on each document that we store in our Cosmos container. And whenever we try to delete an item, we don't actually remove it from the container, but we set the flag isDeleted to true. So it's treated as a update. So the change is still going to be captured by our change feed, and all our subsequent application can still be triggered as usual. And Cosmos offers a great feature called TTL, time to leave. So when a certain time arrives based on our configuration, the item in the document will be completely removed. So we can leverage that to do the actual delete, whereas we can still capture our change by setting the flag. And in the last, I'd like to touch on the last limitation is there is a guaranteed order in the change feed within a partition key value, but not across partition key values. So if the order of the value across different partition key matters to you a lot in your application, then you need to choose a great partition key. So this topic is quite big, so I'm not going to expand too much on this for the interest of time. So we've understood why we want to use those technologies. Let's look at how we can do it. So how we can read from change feed, there's a push model, as you already seen on the screen. We can use Azure function Cosmos DB trigger. It comes with Azure function, and it's no different from other Azure function trigger. But what it does is that it encapsulates a layer that uses the change feed process library under the hood. So the architecture is very similar to how Azure Signal service works, that encapsulates the under hood infrastructure management of Signal library. So we don't need to worry about how to scale, how to troubleshoot, all that. So we can focus on implementing the business logic. And the other way around, there is a pull model. What it means is that the client application need to request the change by themselves. there's no automatic polling, so the client application need to manage that by itself. All right, so we've understand why and how. Let's look at the overall architecture. So starting from the right-hand side, we have our data store, which is our Cosmos DB. Whenever there's a change captured by the change feed built in with Cosmos DB, it can trigger Azure Function Serverless Hub. And Azure Function Serverless Hub has output binding that broadcasts messages to client application via a typical PubSub architecture via Signal service. Now, before we allow the connection being established between client application, our dashboard on a big screen with Signal service, there need to be a negotiation / handshake process happen beforehand. I'll show you the code so it will make more sense. All right, so with a quick overview of the overall architecture, let's see things in action. So if we jump to my subdomain, my domain, we can see that I have a colorful dashboard in front of your eyes. And what is more important is that it's being updated in real time without me needing to click any button to refresh. You'll see that when it happens. But let's just have a quick look at this dashboard. We have an x-axis of the timestamp, and we have a y-axis of different rooms in my sounds track care. So we can see that if we hover over any slot, we'll see the number of people in a room. And we can see that in Lion Room, at a certain time, a 15:15, there are 15 people there. Oh, so it just changed. So you can see we can even hover over the extreme or high or different category so that we know the urgency of take actions to either move some kids back or better arrange the classes in the room. Now, this is cool. I built this application with Vue. And let's move on to Azure and quickly give you an overview. So you must have seen all these services before, so I'll just quickly walk through what they are. So we have a Cosmos DB. It comes with a change feed function, and we have our Azure function, our Signal service, and we have an application inside to monitor our application. Easy. Now, if we jump to the code base, what we can see is that, so if we start from the client end, what I'd like to show you is, in order to connect to Signal service, all we need to do, very simple. We need to install a package, and we import it as we import any other package. After that, all we're going to do is to instantiate an instance of Signal Hub connection via the Hub connection builder, and we'll give it the URL. We can grab the URL from Signal service on Azure, and then bam, done. We're all good. And we can define any functions that need to be triggered on certain event. So here, when a new message arrives, we can update our chart. And we can just start the connection, then that's it. So from client application perspective, it's very easy. So if we look at the backend, so what we have is a bunch of Azure functions. I have a data ingester, which is a function that fetches some data and ingest data to our Cosmos DB. But in real life, the data can be from different sources. It doesn't really matter. Once we have the data, we can look at our broadcasting function. So we define an input binding, which is from Cosmos change feed to our application, that if anything changes in my device trace collection, the function is going to be triggered. And we also define an output binding with Signal, so that any messages that that's generated and hijacked in the function body can be broadcasted to the clients that's connected with Azure Signal service. So if we look at the implementation, it runs this way. We can get a copy of the documents that's a change being captured in the change feed, and we can do our own data massaging and hydration if we need to. And then we can, via the binding, we can define the signal message and populate it. And that's it, done. So our client application can get the message broadcasted by Signal service. Azure handles all that for us and handles all the connection, and handles all the scaling for us. Now, as I mentioned before, there's a negotiation process that needs to happen beforehand. I haven't implemented any logic here, but if we need to, what we can do is that before we return a connection information and allows the client application to connect to us, we can, because this is a simple HTTP trigger, what we can do is that we can grab some identity information coming from the request, either the JW token or the cookie, and do the authentication and authorization if we need to, before we allow a connection by issuing the connection info. So this way is secure. So as we can see, the program model is so simple. With just a few tweaks here and there, we are able to build a great dashboard system. So if you jump back to my slides, as a quick summary, today I've showed you why we want to build a heat map and dashboard system and how it can help to convey the information and help the audience and stakeholders to better find the insights thereafter and take actions promptly if they're concerned about contact tracing or social distancing on their premise. And we've also explored some Azure Serverless technologies that I reckon is a good fit for our solution. I especially focused on change feed design pattern come with Azure Cosmos DB change feed. And I also explained why it can be used as the core engine to help us architect this solution. So we look at the solution design, and we, as part of the software development lifecycle, we've done a quick POC in using TypeScript, married up with Azure Serverless technologies, and prove that the dashboard works. So the management team in my son's childcare is happy. They can watch a big screen, and they will be alerted whenever there are certain amount a certain room exists X number of kids and educators. All right. So with that, that's the end of my presentation. I hope you've enjoyed. And any questions?
Thank you, Patrick. I loved how you use change feeds to address an interesting scenario. We do have some questions from our audience today. The first question that we have on the screen is, can you guide us with another example of the benefit of using Cosmos DB change feed in some other types of applications?
Yeah, sure. All right. If I may bring my screen back again, let me try to find the slides where we have the diagram. So let me just load this diagram. So today, in the dashboard system, I mainly use the first route on the top, which is the event computing and notification functionalities. But another example could be the data movement at the end. So as we all know, the partition key in the Azure Cosmos container is very important. So if we have a query on our Cosmos DB container against the partition key, the performance is optimal and the cost is the most cost effective. However, sometimes we might want to have some other query pattern. So if we have a person document, and most of the time we might query based on the person's email address because that might be the unique identifier. But sometimes we might also want to query about on the person's first name. Then, if we query using the same container with the same partition key as the email address, then the query will go across different partitions. And that's resource consuming and is expensive in terms of the RU that it consumed, the read-write unit. So we need to pay a lot for that query. So an alternative way to do this is that we create another container with the person's first name as the partition key. And we load the original piece of data there. So we can have different query pattern querying different containers. This way, we can save costs and achieve the optimal performance. Now, how can we make sure the primary container and the secondary container keeps in sync in terms of the data, we can leverage change feed. Whenever there's a change on a person's document in the primary container, we can move a copy of the data across to the secondary container. So the data will be in sync. So your application can still perform the queries using different query pattern. Hope that answers the question.
Yep. Thanks, Patrick. So another question that we have from the audience is there a limit on how many instances can scale up to when using change feed?
Here, I guess the question is about how many instances of the consumer applications.
Yes.
No, there is no limit. So you can have your consumer applications hosted in any type of hosting model, either web app or consumer app or even containerized app. So the scaling is really up to the hosting model that you use in the consumer app.
All right. Thank you. The last question that the audience has for you is, when using the pull model, does change feed copy data mutations across to disaster recovery region?
That's a very, very good question. I guess I need to do some research. Personally, due to the complexity in the pull model, because the clients need to request the change. So to be honest, I personally haven't used the pull model before. So I like to do some research and get back to you. As I mentioned before, you can connect me on Twitter so we can discuss this further offline.
Thanks a lot, Patrick, for the very informative session.
Thank you.
I was going to jump in with a question before Patrick runs away.
All right.
Can we get him back? Where did he go? I'll just go get him. Oh, that didn't work. I was really hoping that transition would work with with the production team, but no, all good. If he does come back, I will ask the question of him. If not, we will carry on. So yeah, I've been really enjoying the content so far. Have you got? Is there anything that's particularly stood out to you, Rahul, in what we've seen so far today?
Yeah, I had a lot of fun learning so much about serverless today, Aaron. More so that I love the fact that I'm not restricted by the choice of programming languages, and I can very easily start building applications and get productive from day one when I'm using serverless infrastructure in my applications.
Excellent. Patrick's back. So we did actually just have another question pop in on the Pubble chat that I'll ask you quickly. It's not directly about change feeds, but a question has come in. Does Cosmos DB support any sort of schema validation of the data structures so that you can ensure that the data that's being sent does match anything that you are that you're storing in your data set?
To my knowledge, I don't think there's any out-of-box schema check on Cosmos DB because it's a NoSQL, and a typical non-relational database is that you can store any format, and if the format changed, you can still store it there. But in your application layer, you can always do the validation. So, or you can have you can have a change feed. And you can have an Azure function, subscribe to the change, and do the validation there, and throw exceptions or alerts if there's any change in the schema. But really, if you choose to use NoSQL, that means that you want to cater for the dynamicity in the format of data. So you don't want to do a validation unless the change is too drastic.
So
Excellent. Thanks, sir.